Chapter 11 Uniform Circular Motion 圓周運動 Okay, now this one 11.1 describe circular motion. What is the circular motion? It means that if an object is moving in a circle, then what is the motion of it? Then we want to have this study, circular motion, moving in a circles. Look at this. Here we have certain mathematics. Here, measuring angles in radian. In this case, what will happen? We will define a new quantity. This one call it radian. But why? Because we will not use degree at all in this case. The degree, it can be add or subtraction. We have the subtraction, but it cannot multiply by the other thing. Okay, so in it, the mathematician want to use radian to describe it instead of the angle. Then in this case, we have the conversion from radian, from degree to radian, and also from radian to degree. But what's the definition of 1 radian? Will be related to the circumference. Look at this. Theta is 1 radian. Remember it, 1 radian is not 1 degree. Then what will happen? The radius r, the arc length of it is also r. Then we will call it 1 radian. Then what will happen? We know that for the circumference for a whole circle should be 2 pi r based on the equation. Then what will happen? You can find out for 1 complete circle how many radian in it. Okay? Then look at this. We know that if s is r, s is the arc length, is r, then this one should be 1 radian. Unknown s, then we can use this ratio to find out the number of radian. Now look at this example, half circle and full circle. And look at the full circle. For total arc length of a full circle should be 2 pi r, and then overall should be 2 pi radian. Now, pay attention. From now on, for 1 complete circle, the total radian for it should be 2 pi radian. It means that 2 pi radian is 260 degrees equivalent to it. Okay? Then look at this. The conversion between degrees and radian should be this. 1 degree should be pi over 180. What happened? Look at this. For half circle, pi radian means that 180 degree. Okay, so in ratio, in order to find out how many degree should be pi over the degree. In order to find out 1 radian should be 180 over pi. Here, some special angle. 180 degree means that pi. 90 degree should be half of it. 180 degree pi radian. 360 should be 2 pi radian. And you should know that this conversion between it. Part B. Part B will be describing a circular motion. Lastly, in Part A, we know that new unit for it is radian. But of course, you do not know that why we need to introduce this. Okay, so in Part B, we will focus on it in physics. Here, to describe how much an object turns and how fast it turns. Look at this. Here, we also have one new physical quantity, is angular displacement. In the previous chapter, you know that was a displacement, 位置的移動. How about this one, angular? Angular means that related to angle. It means that the change in angle. Okay, so look at this. At the angle through which an object turns. For example, if this object turns 90 degrees, then we will say that angular displacement should be 90 degrees. But we will not use degree, we will use the radian. For 90 degrees should be pi over 2. Okay, and also displacement should be a vector. Other than the magnitude, it means that the pi over 2 radian, other than it, we also have the direction. For the direction for angular motion, okay, 角位移啊，呢個角度嘅位移。Then this one we will choose direction. One is the clockwise, the other one should be anti-clockwise. And also, if we have the displacement, we also have the velocity, 角速度。This one we will say that omega. Here, to describe how fast an object turns, then by definition should be the displacement over the time. But now if we haven't displacement, we have angular displacement. So angular displacement over time should be the angular velocity. The unit of it should be radian per second. Then here, if the angular velocity is a constant, then this one we will say that uniform circular motion. Exactly the same in the last topic. Uniform motion means that constant velocity. Here should be the constant angular velocity. And also we will have the other physical quantities will be the period 周期. What is it? The time for an object to turn through one revolution. Revolution means that 繞動一周，圈啊，兜幾多個圈？一個圈。Okay, so here, what is the meaning of period? It means that in order to complete one circle, the time spent on it. Okay, what is it? This one we will say that time t. This time t is a special one for one complete cycle. In order to complete one cycle, the total radian for it should be 2 pi radian. The time for it should be t. Then, by definition, angular velocity should be total radian, the total angular displacement over the time taken should be time for one period. Then we will have this relationship. Please remember this equation. Now look at the first example. Here, what is the period of the minute clock of a minute arm of a clock? For the clock, for the minute, it will turn around one cycle. Okay, one complete revolution within 1 hour. Then you should try to find out the time and the total radian for it to travel should be 2 pi and 60 minutes. Okay, and part B, how large is the angular displacement of the minute arm in 20 seconds? Should be like this diagram. Okay, you should measure the total angular displacement in this case. Should be 1/3 of one complete cycle. 1/3, how to get it? Should be 20 minutes over 1 hour, should be 60 minutes. Then the total angular displacement should be 2 pi over 3 radian. How about this? Angular speed of the minute arm. By definition, angular speed similar to angular velocity, just only negate the direction. For one cycle should be 2 pi radian. For one cycle, the total second in it should be 60 times 60. Should be this. Okay, keep going. Relating angular and linear motion. In the last topic, we know that this angular and linear motion. In a uniform motion, we will have angular speed and linear speed. Okay, remain constant. Both of them should be a scalar because both of them should be speed. But what's the difference between linear and angular? Of course, linear should be related to linear, angular should be related to angle. Now look at the following diagram. The direction of the velocity changes continuously. It means that accelerating. Look at this. If we have an object moving in a circle in different time, for the first one, 0 time, period t, okay, or 1 complete cycle should be period t. Move forward 90 degrees, then the total time for it should be a quarter of the period. Move forward 180 degrees, pi radian should be pi over 2, t over 2. For 270, okay, should be this time. Then what will happen? What can you see? You can see v, all the v, the length of the vector should be the same. It means that they will have the same speed. But how about the direction? They are not the same. For the first one should be up, second one should be to the left hand side, downward, and right hand side. The direction of it is changing. Then here, angular motion are described by angular displacement theta and angular velocity omega. Linear motion described by the arc length and linear velocity. This linear velocity should be tangential direction. They are not the same. So look at this diagram. For the arc one, should be radial. Okay, this one should be angular displacement and also the omega. But for the straight line, okay, the straight line vector should be tangential. This one should be linear. Now we want to link up these two quantities. From the definition, arc length over radius should be angular displacement theta. Okay, so look at this. Arc length, okay, angular, this one, arc length should be, the arc length here should be r theta. Here, like that. This diagram tells you already. Now, if you use the arc length over time, this one should be the speed, okay, matter only. And then over the time, then you can find that this relationship, v is equal to r omega. Omega should be angular velocity. This one is angular velocity. This v should be linear velocity. How to link them together? We will use the radius to link up it together. Then this one is the linker between angular velocity and linear velocity. Okay? And here, next case. What is the meaning of omega? You can use this one revolution, 2 pi radian. The time should be 1 period. Put it in it, then we can find that linear velocity should be 2 pi r. 2 pi r means that the total circumference. It means that the arc length of a whole circle. And the total time for it should be 1 period. Then we can find out the linear speed. Circumference over the time should be the linear speed. Up to now, you can find out the linkage should be this. Remember it. Now this one, example 2, Singapore fire. You can see that this ferris will be like that. 2 cycles, it means that 2 revolutions in 1 hour. It means that 1 cycle should be half hour. Then here, estimate the angular speed. Angular speed. Okay. Then what should you do? Try to find out the period of it. Should be this. For 1 cycle, should be 1,800 seconds. And also for 1 cycle, should be 2 pi radian. Then we can find out the angular speed should be this. Pay attention on the unit. Should be radian per second. Part B. How about the linear speed? Linear speed, you can apply the formula. Relate linear and angular. Should be this. R omega. In part A, we know that omega. We know that the radius should be this. How about this? If we want to build up larger one, it means that the circle will be bigger. Then what will happen? Okay. Here, what would their angular and linear speed change? Even this one is bigger. The circumference is bigger. But how about the linear speed? You can keep it unchanged because depends on this one. 2 pi, it means that 1 revolution should be 2 pi radian. the period should keep the same, so omega should be the same. But R is increased, it means that this. Omega no change, R increase, it means that linear speed will be increased. Then what will happen? Go back to this diagram. Here, you feel that the linear velocity should be this. If R is increased, you feel that should be this. You can see that they have the same angular omega, but different R. Then you will feel that here, this V dash and this V dash will be greater than V. You will feel more exciting here, because you will feel that the linear speed will be higher than the previous one. Okay? Example 3. Okay. Okay, go back. Should be Ch11.1. Okay, Ch11.1. In this example, try to test the conversion between degree and radian. Here, 360 degree should be 2 pi. How about pi should be 180 degree. For the other thing, just only do the calculation. Okay. This one 2 pi or this not over or 2 pi or 6.28. Okay, you can use the calculator to do it. How about next? This one will be the record player 留聲機黑膠唱片。When the player operates a circular disc spin uniformly on a turntable, consider the portion A and B. State whether the following quantities of the portion are the same. Now what happened? Period. It means that for A, it will move through one cycle, and then how about B? Move through one cycle. Are they the same period? Of course, yes. 當大家玩緊揼揼轉 okay, you should pay the same time to complete one cycle. How about angular speed? Angular speed, it means that omega. The time for it to turn one turn should be the same. Okay, A and B should have the same omega. How about angular velocity? Angular velocity exactly the same as omega. But what is the difference between A and B? Speed and velocity. Speed only the value. Velocity we will add one more, is the direction, clockwise or anti-clockwise. Okay. How about the linear speed? Should not be the same. When you play the merry-go-round, okay, 揼揼轉, you will feel that A here will be more exciting because higher linear speed than B. Linear velocity the same, because the speed is not the same. Linear velocity should not be the same, but of course the direction should be the same, downward. Okay, the other one, Y 旋轉木馬, okay, like that. Give you one revolution every 20 seconds. Find her angular and linear speed and period t. Period t should be 20 seconds. I think you should know that. One revolution, the time for it. How about angular speed? Angular speed, one revolution should be 2 pi over t. Then should be this omega. How about the linear speed? Should be related to the radius R, 5 meters. This.